Welcome back to Click Future, where your future is a click away. Today we're diving into a story that's reshaping the global balance of power in ways most people don't even realize. While the world has been focused on traditional politics, a revolution has been taking place in the laboratories of quantum computing. And China just made a move that has sent shockwaves through the corridors of power in Washington, Silicon Valley, and research institutions worldwide. What you're about to hear isn't science fiction. It's happening right now, and it's going to change everything from how we secure our communications to how we discover new medicines, from how we predict weather patterns to how we understand the fundamental nature of reality itself. Albert Einstein once called quantum mechanics spooky action at a distance. But what's truly spooky is how far ahead China has pulled in this race while most of us weren't even paying attention. The quantum revolution isn't coming, it's here. And the country that masters it first will hold the keys to technological supremacy for the next century. Today we're going to explore how China achieved what many thought was impossible, why the United States is scrambling to catch up, and what this means for every single person watching this video. To understand the magnitude of what just happened, we need to step back and grasp what quantum supremacy actually means. Traditional computers, the ones powering your smartphone, your laptop, even the most powerful supercomputers in the world, process information using bits. These bits can be either 0 or 1, on or off. It's binary, and it's been the foundation of all computing for decades. Quantum computers operate on an entirely different principle. They use quantum bits, or qubits, which can exist in multiple states simultaneously through a phenomenon called superposition. Imagine flipping a coin that could be heads, tails, and somehow both at the same time until you observe it. That's the quantum world, and it's this bizarre property that gives quantum computers their incredible power. Here's where it gets really interesting. While a classical computer with 300 bits can represent one of 2 to the 300 possible states at any given time, a quantum computer with 300 qubits can represent all 2 to the 300 states simultaneously. The numbers are so large they're almost incomprehensible. We're talking about more possible states than there are atoms in the observable universe. China's latest quantum computer, which they've named Zhujiang 3.0, has achieved something that would have been considered impossible just a few years ago. In a recent demonstration, it solved a specific mathematical problem in 200 seconds that would take the world's most powerful classical supercomputer approximately 2.5 billion years to complete. Let me repeat that, 2.5 billion years versus 200 seconds. This isn't just an incremental improvement. This is a fundamental leap that represents what scientists call quantum supremacy, the point at which quantum computers can perform calculations that are practically impossible for classical computers. And China didn't just achieve it. They've now demonstrated it multiple times with increasingly sophisticated problems. The implications are staggering. As Neil deGrasse Tyson has pointed out, when you have computational power that can simulate the universe itself, you're not just changing technology, you're changing what it means to understand reality. China has essentially built a machine that can peer into the fundamental structure of the universe in ways we've never been able to before. The response from the United States has been swift and, frankly, panicked. Within weeks of China's announcement, emergency meetings were called at the highest levels of government. The Department of Defense, the National Security Agency, and the Department of Energy all convened crisis sessions to assess the implications. Why the panic? Because quantum supremacy isn't just about bragging rights or scientific prestige. It's about national security, economic dominance, and technological sovereignty. A country with advanced quantum computing capabilities can break virtually any encryption system currently in use. That means they can potentially access classified government communications, steal industrial secrets, manipulate financial systems, and compromise the digital infrastructure that modern society depends on. Elon Musk, never one to mince words, recently tweeted, "Whoever achieves quantum supremacy first doesn't just win the technology race, they rewrite the rules of the game entirely." This is bigger than the space race, bigger than the nuclear race. This is the race for the future of human civilization. The United States has responded by announcing a massive increase in quantum computing research funding. The National Quantum Initiative Act, which was already providing billions in research funding, has been expanded. Private companies like IBM, Google, and Microsoft have been brought into emergency partnerships with government agencies. Universities across the country have been asked to prioritize quantum research and fast-track PhD programs in quantum physics and quantum engineering. But here's the problem. China didn't just stumble into this breakthrough. They've been systematically building their quantum computing capabilities for over a decade. While the United States was focused on other priorities, China was quietly investing hundreds of billions of dollars in quantum research, building state-of-the-art facilities, and recruiting the world's top quantum physicists. The Chinese approach has been fundamentally different from the American model. While the US has relied primarily on private companies and university research, China has treated quantum computing as a national priority equivalent to their space program or nuclear weapons development. They've created dedicated quantum research cities, established quantum communication networks spanning thousands of miles, and integrated quantum technology development into their broader economic and military strategy. What makes this situation even more complex is that quantum supremacy isn't just about building faster computers. It's about fundamentally changing how we approach some of the most challenging problems facing humanity. Quantum computers excel at simulating quantum systems, which means they can revolutionize drug discovery, materials science, climate modeling, and artificial intelligence. Consider drug discovery. Traditional pharmaceutical research involves testing millions of molecular combinations to find effective treatments. This process typically takes 10 to 15 years and costs billions of dollars. A quantum computer can simulate molecular interactions at the quantum level, potentially reducing drug discovery timelines from decades to months. China's quantum advantage could give them a massive head start in developing treatments for cancer, Alzheimer's, and other diseases that have plagued humanity for centuries. The same principle applies to materials science. Creating new materials with specific properties, superconductors that work at room temperature, ultra-efficient solar cells, batteries with unprecedented energy density, requires understanding how atoms and electrons interact at the quantum level. China's quantum computers could accelerate materials discovery in ways that give them decisive advantages in clean energy, electronics, and manufacturing. But perhaps most concerning from a national security perspective is the intersection of quantum computing and artificial intelligence. As Brian Greene, the renowned theoretical physicist, has explained, quantum computers don't just process information faster, they process it in fundamentally different ways that could unlock new forms of machine intelligence we can barely imagine. Current AI systems are limited by the computational power of classical computers. They can recognize patterns, make predictions, and even generate creative content, but they're still fundamentally constrained by binary logic. Quantum computers could enable AI systems that think in ways more similar to how the human brain actually works, processing multiple possibilities simultaneously, making intuitive leaps, and solving problems through quantum-inspired algorithms. China's quantum advantage could translate into AI systems that are not just faster or more efficient, but qualitatively different from anything the United States or other countries can develop. We're potentially looking at a future where China's AI systems can solve problems, make discoveries, and develop technologies that are simply beyond the reach of classical computer-based AI. The geopolitical implications of China's quantum breakthrough extend far beyond technology. We're potentially witnessing the emergence of a new form of technological colonialism, where countries with quantum capabilities can dominate those without them in ways we're only beginning to understand. Consider cybersecurity. Every encryption system currently protecting our digital infrastructure, from online banking to government communications to personal privacy, is based on mathematical problems that are extremely difficult for classical computers to solve. But for a sufficiently powerful quantum computer, these problems become trivial. China's quantum capabilities could potentially give them the ability to access any digital system anywhere in the world at any time. This isn't theoretical. China has already demonstrated quantum communication networks that are theoretically unhackable, while simultaneously developing quantum computers that could break everyone else's encryption. They're building both the ultimate shield and the ultimate sword in the digital realm. The economic implications are equally profound. Quantum computing could revolutionize logistics, financial modeling, supply chain optimization, and market prediction. A country with quantum supremacy could potentially manipulate global markets, predict economic trends with unprecedented accuracy, and optimize their own economic systems in ways that give them insurmountable advantages. Charles Liu, the astrophysicist and science communicator, has warned, "We're not just talking about a new technology. We're talking about a new form of power that could reshape the global order as fundamentally as nuclear weapons did in the 20th century. The difference is that quantum supremacy affects every aspect of modern life, not just military capabilities." The response from other nations has been telling. The European Union has announced a massive quantum computing initiative. Japan has partnered with the United States on quantum research. Australia, Canada, and the United Kingdom have formed a quantum alliance. Even smaller countries are recognizing that quantum technology isn't optional. It's essential for maintaining technological sovereignty in the 21st century. But building quantum computers isn't like building conventional technology. It requires expertise in quantum physics, advanced materials science, precision engineering, and software development that takes decades to develop. The scientists and engineers capable of building quantum computers are among the rarest and most valuable human resources on the planet. This brings us to one of the most critical aspects of the quantum race, the battle for human talent. There are estimated to be fewer than 10,000 people worldwide with the expertise necessary to design and build quantum computers. China has been aggressively recruiting these individuals, offering salaries, research budgets, and facilities that are often impossible to match elsewhere. The United States has responded by launching its own talent recruitment initiatives, but they're facing significant challenges. Many of the world's top quantum physicists are already working in China or have been recruited by Chinese institutions. American universities are struggling to compete with the resources that China is offering to quantum researchers. Jana Levin, the cosmologist and quantum theorist, has observed, "The quantum revolution isn't just about building machines. It's about building the human knowledge base necessary to understand and control quantum systems." China has recognized this and has been systematically building that knowledge base while other countries were focused elsewhere. The talent shortage is so severe that some experts predict it could become the limiting factor in quantum development. You can't just throw money at quantum computing and expect results. You need people who understand the deepest principles of quantum mechanics, who can design quantum algorithms, who can engineer quantum hardware, and who can solve the countless technical challenges that arise when you're trying to harness the strange properties of the quantum world. China's approach has been comprehensive. They've established quantum research institutes at major universities, created specialized quantum engineering programs, and even built quantum research cities designed specifically to attract and retain top talent. They've also invested heavily in quantum education, ensuring that the next generation of Chinese scientists will have the knowledge and skills necessary to maintain their quantum advantage. So where does that leave us? The quantum race is far from over, but China has established a significant lead that will be difficult to overcome. The United States and its allies are mobilizing resources and talent, but they're playing catch-up in a field where being second place might mean being irrelevant. The next few years will be critical. We're likely to see massive investments in quantum research, aggressive talent recruitment, and possibly even quantum technology export controls and trade restrictions. The quantum race could become as defining for the 21st century as the space race was for the 20th century. But there's also reason for optimism. Quantum computing is still in its early stages, and breakthrough discoveries could come from anywhere. The principles of quantum mechanics are universal. They don't belong to any one country or culture. Innovation in quantum computing could emerge from unexpected places and change the competitive landscape overnight. What's certain is that quantum computing will transform our world in ways we're only beginning to understand. From revolutionizing medicine and material science to enabling new forms of artificial intelligence and reshaping global power structures, the quantum revolution is just getting started. As Einstein himself said, the important thing is not to stop questioning. The quantum world is full of mysteries we haven't even begun to explore, and the countries and institutions that embrace that spirit of questioning and discovery will be the ones that shape the future. The quantum race is more than just a competition between countries. It's a race to unlock the fundamental secrets of reality itself. China's recent breakthrough represents a significant milestone, but it's just the beginning of a journey that will transform every aspect of human civilization. The question isn't whether quantum computing will change the world, it's whether we'll be prepared for the changes it brings. The future belongs to those who understand and master the quantum realm, and that future is arriving faster than most people realize. Thanks for watching Click Future, where your future is a click away. If this video opened your eyes to the quantum revolution happening around us, make sure to subscribe and hit the notification bell. The future is quantum, and we're here to help you understand what that means for all of us. What do you think about China's quantum breakthrough? Are you excited about the possibilities or concerned about the implications? Let me know in the comments below, and I'll see you in the next video where we'll explore what life will be like when AI controls everything.